Hey everyone, welcome to my channel. Let's share my screen. Uh, Completed something like streaming last time. So I think we not yet completed, but yeah, we started learning on that, and we learned a bit of it. So let's see. So in the last session, the question that was asked about is in streaming based on so ID and within 10 minutes window. So hint is deduplicate plus watermark. So I was not aware of anything about the deduplication process. So I said like no idea. So now GPT has answered this. So I'm just gonna continue on those lines. So remove just a second. Okay, remove duplicate streaming events while allowing late data up to 10 minutes. Okay, so core idea in streaming dedupe also needs state. The Spark sees an ID. It must remember. Okay, so I already saw this ID. But if the remembers forever, memory grows faster. So okay, watermark limit is okay. Based on the watermark limit, it seems to be the removal process as well. It needs to consider those records and those transactions maybe in the data frame, and it needs to read them and finally do the deduplication process, and after that proceed with the next operation. So that's what I understood from this. So okay, the correct pattern is watermark so and so on the event type and drop duplicates on particular ID. So it says, I mean, the code looks little simple, but we need to explore that how this works in a practical level. So for that, I mean, yeah, we can. Okay, so says late data is allowed up to 10 minutes. Okay, why this works? Watermark item, watermark event time 10 minutes, and says late data is allowed up to 10 minutes, of course, and drop duplicates. Just a second. Mm, no, no, okay, okay, okay. Sorry for the disturbance. Okay, next, Spark keeps dedupe state only as long as needed, then classes and then cleans old state. Of course, it all depends on the state only. So mental model is like Spark keeps a temporary memory like ID 101 scene, ID 101 scene, ID 103 scene. After watermark process, old IDs can be forgotten. Okay, yeah, this is the best way of doing it. Okay, important nuances. First, streaming dedupe watermark is typically used within event time column, so Spark can safely evict old dedupe state. So in the last session, we already learned the similar way. Of course, you are not, even though we are not up, you're not doing the dedupe anyway. But for the other operations as well, it considers a particular window, and in that particular watermark, so that it will keep the state for the particular operation, whatever it's supposed to do. So the same way, deduplicate also it's one of the grouping operations. So it will do in the same way, but the state is the main key aspect here. So how to keep the state of a particular thing, we need to get an idea. So once we got an idea, then I think yeah, it will be very easy to perform that operations. Okay, let's see. Let's go further. Uh, so with no matter mark, what's the problem over time? So I think in this case, I believe the deduplicate will consider whatever the incoming records or available records at that time as a single group, a single group and performs the corresponding deduplication operation. But what happens is, like, if it is not specified any limit, right, it will keep on piling up that um, particular state item. Like, for example, it the processor or whatever the internal inbuilt aspect will keep the state, and that state will be keep on piling up. I think I'm gonna answer. I'm gonna answer this. The state is keep on piling up. That's what I'm supposed to say. But let's see. It is taking time. State will be piled up. State will be piled up, I believe. So that will eat up a lot of memory. Uh, the only problem I saw with ChatGPT right now is uh, it's taking a lot of time to process this audio conversation. So I don't know. Voice to speech conversation is taking time, or maybe my system definitely not slow, because all the other system as well behaving in the similar way. Mm, so I think that is the reason. So let's see. It's still not happening. State will be piled up. State will be piled up again. So I believe so that will eat up a lot of memory. That's what I'm gonna say. Let me answer this, and let's hope for the response. But it should be quick. That is the only drawback I could say right now. So whoever is watching my video, try to do it in 1.5x speed or maybe 2x speed, so that it won't frustrate you at least. Mm, okay, exactly right. Okay, refine this. Without watermark, Spark keeps all scene IDs forever. State keeps growing. Memory usage increases indefinitely. So that is correct. So why this happens? Drop duplicates on ID. Spark must remember every scene ID, of course. No watermark, no eviction policy. Okay. Streaming unbounded state grows faster. Okay, that's fine. Correct pattern dedupe with time. Okay. That is a correct pattern. Then we need to know how to apply this apply this perfectly. But let's see. I don't know. I'll say let's continue. I don't know why it is stuck. Uh, why it stopped? I don't know. Why it is stopping? Why it is stopped? I don't know. Let's wait for that. Let's wait for some time. Okay, let's continue. I'll say. Let's see what it returns. I'll be on mute for a while. Yeah, sorry. Welcome back. Let's continue with stream join. Okay. Stream join. I think I'm planning to. Okay, let's continue this. Instead of doing about stream join, I would just want to refine what I have learned just now. So before going further, I want I want to overview what we have learned about streaming, structured streaming, structured streaming, then continue stream join, then continue stream join. So that's what I said, but let's see what it responds. I think it'll get the overview, but in between, like we can read out what it has given. So what AI has given, we can just give a shot. Set it is again doing like this. So good. Let's continue with the stream joins one step at a time. Okay, stream join stream plus static, stream plus stream, static plus static, normal batch. And I don't know what these cases are, but we'll try to learn a bit step by step. The important one of the streaming are one and two. Okay, I think stream static, stream plus stream. Streaming events coming from Kafka files. Okay, static customer master table from Parquet or Delta. Okay, so what I think it seems from a streaming event to a static table it is writing. So that's I think it is saying. Okay, next. This is simpler. Okay, why this is simpler? Event join customer static. Customer static is a static table name actually, and customer ID and left, of course, that event stream is this Kafka. I think Kafka event, or maybe it's a file. I'm not sure, but let's see. Static table does not keep changing during the query. Spark does not need streaming state for both sides. Yeah, because it's a static table, it needs not to keep any state for that particular thing. Only the Kafka queue or the file that is in streaming event, I think that needs to be taken care. The rest of them it will be manageable. Usually easier and cheaper than stream join. Okay. Both sides, if it is streaming, then what needs to be done? I think it is saying that. Next, click stream. Impression stream, clicks stream, impression stream. Okay. If you want to join on same add id close event times, this is harder because both sides keep receiving data. Must Spark must keep state for both the streams. Watermark, because watermark becomes very important. Okay, very important. Next, why watermark matters even more in stream join, because both sides stream watermark will have a certain time window. I think I don't know about the common time window it has for both of them, how it can deal, but I think, let's see. If Spark joins two unbounded streams without time control, it must keep old rows from both sides forever. Memory grows forever. For example, I did not able to understand here. 1 minute. If Spark joins two unbounded streams without time control, okay, it must keep old rows from both sides forever. Memory grows faster. Of course, any stream, if you don't specify any time window, it will obviously, the memory will eaten by the state, whatever it is keeping for the reference. Okay, next, so for stream joins, you typically need watermark on both sides, time condition in join. Mhm. Simple conceptual example: left stream, right stream, join only on order id. Spark may need to wait forever for. Okay, we'll come to this. We'll come to this. We'll try to learn about the structured streaming. The overview of that. So let's see that first. Okay, so let's consolidate everything early before moving to joins. This will lock your understanding. Yes, of course. Structured streaming. What's your learn? So clean summary is core ideas. Streaming is equals to unbounded data, of course. Data keeps coming. No fixed end, of course. Processing model. Spark process data in micro batches. Stream micro small batch process repeat. Stream micro batch stream small batch process repeat. Stream small batch process repeat. Okay, so state memory Spark is equals to the memory Spark keeps across batches. So this, to save the state based on the state type, it will do grouping, do dedupe, or join all the other stuff. So in that case, memory Spark keeps across batches, of course. Group by user count. Okay, Python group by user count. Spark remembers counts per user. Yeah, so based on the each user, it'll count, of course. Next, problem is the infinite state without time control. Like if you don't have time control, state keeps growing, memory explodes, of course. Watermark is critical. Why it is? Watermark controls the state cleanup. So that's why, see, it's all the game of a memory. So if you have proper memory and proper resources on the system, you could able to perform the operations very well manner. So that's the reason, mm, all the actions, all the mechanisms, whatever it is there, I mean, that is tied up to the state. uh, so state and the memory, exclusively memory. So for that memory management, all the other options like cleanups and state management and watermark window and everything come in picture step by step based on the needs. Okay, next, mm, allow late data up to 10 minutes, drop older data. Watermark equals to control state cleanup, meaning allow late data up to 10 minutes. Yeah, of course, allow it drop older data, of course. So you mentioned watermark that group by window specific time. So if you can group by on the watermark basis, I believe, but so this stuff records it need to be considered for a particular set of operation like group by. So that will be defined by the window. So that will be window event time 5 minutes needed. So Spark knows grouping is complete. Okay, when it can clean the state. So at the end of 5 minutes, the grouping will be completed and it will consider for the further operations. And of course, the state cleanup will happen after that, and the next batch will take up that state. So it will continuous cleanup and continuous management of memory is happening because by hand in hand operations with watermark and window that will help you to clean up the memory, and that will help you to keep the environment ready for the next process. Okay, output modes like append, update, and complete. These are the output modes. Like new rows only you need to add, and update is the change rows you need to add, and complete is a full result. Next checkpoint is for fault tolerance. Is like, whenever in any case, any unfortunate situation, at any point of time the process fails, then it needs to continue the process from the point it failed. So that is mainly help in the fault tolerance perspective. So the fault tolerance can be achieved by using checkpointing. So that is the advantage. Checkpointing is for the fault tolerance, and state is for the memory management actually. Watermark is like a up to that much time the data will be considered older data, remove the older data. And window will allow you to do the perform that operation in that particular time limit. So every 5 minutes the grouping of the data will happen, and once that window pass, so automatically the next grouping will start automatically, because the entire process, it won't stop anyway. The once it is started, and it will continue to process till the end of like mid of night it'll be it'll just stop once and it'll rest for one, will restart again. The maybe it depends on the needs. Okay, next, deduplication pattern here is like if you want to duplicates on a particular level, then watermark will help you to understand that. So within that watermark window, it will consider pile up and it will do drop deduplicates in that particular area, and it will go to the next process. So the key mental model is very important is window defines grouping, watermark define cleanup, state stores results, checkpoint save everything. So common mistake. No watermark is a memory issue. Watermark without window, no cleanup. Confusing event time versus processing time. Okay, no checkpoint is no recovery. So now let's continue stream join. Okay, the question what they asked is why is join key alone not enough in stream to stream join? So before going further, let's read out the information what it was given for the stream join. Okay, stream join, it's the next concept. So stream plus static, three type of common cases like stream plus static, stream plus stream, static plus static. It's normal batch join. This is normal batch join, we are already aware. This is related to stream. Like for example, your input thing is a streaming, and your output thing is static, like maybe a static table you're writing to, or any static file you're going to create. So that is stream to static and stream to stream. For example, you need to read from the stream itself and you need to write to the stream itself. So in those cases, that like stream to stream, we can say, um, okay, let's read out what it says. Like stream plus static. This is the regular case we already did in the past, in the earlier sessions. Like streaming events coming from Kafka files, static customer master table. Okay, in those cases it will be used. Why this is a simpler is static table does not keep changing during the query. Spark does not need to need streaming state for both sides. Only one side is enough. Usually easier and cheaper than stream join. Stream join, in this case you need to keep both of the states alive until that state time or window time or watermark time ends. Then only it needs to go with the next operation, so that it'll create a boundary between this micro batch to the next micro batch. So that's why stream join needs to keep the state for the both. So yeah, that is one case. And next, why watermark matters even more in stream joins, that I just now told. Watermark is very mandatory because it needs to keep both sides forever, both sides. Otherwise it will, the memory will be piled up with by states, whatever the states it's going to create from both the ends. So that will create a memory issue. Yeah, memory goes forever. Watermark join. So far for stream joins, you typically need watermark on both sides. Time condition in join. Okay, time condition in join is which time zone, which time, at which time we need to map with another time. So that's the thing. For example, here is given like a simple conceptual example is like order ID. If you want to join on order ID, it will take forever to wait forever for the future matches. Just keep on waiting. So you need to include time as well. So it needs to match that order ID and the corresponding timestamp. If it is not having a timestamp, then it won't. Maybe it'll in between. I will go further on that line. So, but if you say match on order ID, the event time within 10 minutes. Spark knows when old rows can be discharged. So it need not to keep all the thing in the memory. So it will discharge based on the time limit, and after that it will go with the next micro batch. Pattern for stream join. You usually do something like left equals to left dot with the watermark, event time 10 minutes, right equals to right dot watermark, event time 10 minutes. Both are 10 minutes here. Join key, then join key with key condition, time range condition as well. Okay, I don't know the code actually, but let's see. Why join key alone not enough for save stream join job? So this is so simple to answer is, as though the simple answer is memory. Oh man, come on. So the simple answer, I'll type here instead of writing. I'll type here. So what it will do, if no time limit, This will, I think, process will be waiting forever. Will be waiting forever. Waiting forever. So memory will be full. That's simple way I'll give, but it will refine that answer. I know. Um, but let's see. Okay, exactly, that's the right idea. Refined answer it will give, of course. Giant key alone is not enough because Spark may wait indefinitely for future matching records, leading to unbounded state growth. State will be in the memory, so the memory will be lost, of course. So now let's build a stream join properly. Core requirements is to watermark in both streams. Join key condition and time range condition both needs to be mentioned here in this. So why time condition is needed, I think the explanation is already done. Without time condition, Spark must wait forever for matches, cannot clean state. With time condition, what happens is Spark knows when data is too old and can drop it immediately based on the time lapse. Okay, and step by step operations it has given two streams. One is orders, Spark stream join orders and payments. Okay, load payments or format JSON. Okay, this is the two sources it has given. Two data frames, orders and payments. Both are JSON format, and it has some path as well. Like next, add watermark. Orders equals to orders dot watermark of 10 minutes. Both have a watermark as 10 minutes. Next, join condition. Join on same order ID. Event time within 10 minutes. Of course, both having the same 10 minutes time window. But even though the time window is there, you need to specify exclusively in the join condition as well. So for that, I think the code will be like, expr, okay, expr order id and payments, what it is, join payments. Of course, orders table needs to be joined with payments on order id equals to payments order id, and payments event time between orders event time and orders event time plus interval 10 minutes. Orders event time, so orders is here, orders is a left table here, and payments is a right table. It needs to join with this, and then the join key area it has to be an expression. That expression will have a detailed information about the event time. Event time is should be one of the column, I believe. Yeah, event time in the watermark, it's actually both of the watermarks are defined like this, so you need to exclusively specify, I think. But here there is a small confusion I have is, it is both are assigned to the same data frame, but I'm not sure how it's gonna work. Maybe practically I need to see that later. Let's see. So in this case, what I'm doing is I'm specifying a key at the first point, and after that the and payments dot event time between orders dot event time is the current orders dot event time plus 10 minutes. That's what it says. So from that time to next 10 minutes time, like for example, it has This particular data set has some column like 4 o'clock, and 4 o'clock plus 10 minutes, till that point of time, whatever the records it receives, it will take them and it will do the join for that. So, and it's the join type is an inner join. Okay, in our session we have clearly discussed about the different type of joins. So I think you can just go back to the old video and have knowledge about it. Next, what happens internally is Spark keeps state for both streams, of course, matches records within the time range. The time range plus 10 minutes, like 4 to 4:10. That that in within the time limit, whatever the record it receives continuously, those records will be considered as a guru, considered as to be joined in both the tables. Okay. uh, Key interview points is stream join needs watermark on both sides, of course, needs time condition, yes, otherwise memory explosion will happen. Quick check. Okay, which of these in is mandatory for safe stream join? Join key watermark time condition 3. Join key watermark time condition, as per the understanding we have, I think this will be correct. uh, let's see the next. Hmm. I will try to explore this entire chat from start to end at the end of my last video, I believe, for the reference purpose. So let's see how it's gonna work. uh, why tight interview ready? Yeah, you need. Yeah, that's correct. Okay, whatever the previous knowledge we have, we need to answer this question actually. Given time stream orders and payments with the order ID and event time. Write join condition only use EXPR to match order ID. Okay, so it will be having orders dot order ID. Orders dot order ID equals to payments dot order underscore id underscore id. This is one, and the event timestamp is like orders dot event time and orders dot event time plus 10 minutes. I think minutes, last time we made a mistake. We did a minimalistic approach. The 10 minutes plus 10 minutes. No, in small letter. Mi minutes. Okay, I think these are the two answers for this, but let's see. Mm, just fix the syntax. Okay, syntax may. What is the syntax I need to fix here? Okay, the interval 10 minutes. Okay, that is wrong. Plus 10 minutes, not plus 10 minutes. Plus interval 10 minutes. Okay. Okay, good attempt. You got the structure of just fixed syntax. Okay, what is the syntax? Fixed needed spellings. Okay, order ID, event time, that is wrong, and not comma. Here I think, and it's already there. I think I don't know why it is. Okay, interval 10 minutes. That is okay. Interval 10 minutes. I forgot. I think that is the thing we need to see. Why we use interval 10 minutes instead of just plus 10 minutes? This really I don't know. To specify that is an interval, I think that is the answer, but I'm not sure. I'm still little, that's what I'll answer, and let's see whether it is correct or not. I think I need to answer like to specify that's an time interval. Maybe that's the best word I can use here. But yeah, let's see. Okay, so you got the structure. Okay, you are on the right track. Let's make it precise. We use interval 10 minutes to explicitly define a time duration. So Spark can correctly perform timestamp authentic. That's the good answer. I mean, I gave almost the same. Okay. Why not just 10 plus? Because event time is a timestamp. 10 alone has no unit. Spark needs a type to time interval. So that's the reason it is not just okay. Okay, so memory rule timestamp plus interval is valid. Timestamp plus number invalid or ambiguous because it could not able to understand like it's a time interval. So that's the problem. Next, you are now obviously right. I mean, like mm, same type of data types. Like if you do any arithmetic operations, you will do same type of data types only can be clubbed together. So yeah. Next, you are now covered structured streaming deeply. You now understood state, watermark, window, checkpoint, output modes, deduplication, stream joins. This is a strong production level foundation. Final phase is the real interview scenario. Let's simulate a Fang style question. Okay, what is a Fang style question here is you are given real time event stream, user ID, event time, remove duplicates based on user ID, count events per user every 5 minutes, handle late data up to 10 minutes, write without write output to console. Okay, the entire it's an exercise we need to write now. Let's write it. So as per my knowledge, I have a knowledge of to recognize the code but not to write exactly the code. Read stream, add watermark. Like, let's go back and I'll see the code and I'll see and write since it is pretty early for me. So the stream starting is like, I can say read stream spark dot read stream dot format. So what is the format here specified as? The format is just count. It does not have any join, so it will be a single real time event. Like I can say user ID and event time, it is there, right? So user DTL, I'll say user DTL, user DTL equals to spark dot read stream dot spark dot read stream dot format. JSON, I'll put JSON. Load is events, I'll say events. Okay. uh, spark dot read stream read, I think R is capital, maybe confusion on read stream. R is capital or not? R capital or not? R capital not. So these things, you have a practical experience, you will obviously know. Spark dot read stream dot, I think format specification it gave. Let's see the format real time event, and I can do CSV as well, I believe, right? I mean, it's not exactly, it needs to be, it's need to be only format is CSV dot, what else, from, I think it's from from maybe load dot load, I think it's events. Okay, this is one line. User DTL is the one. Next line would be add watermark for the same. For adding watermark, it's like watermark data frame dot watermark dot event time comma 10 minutes. 10 minutes exclusive internet with watermark, not watermark, with watermark. Okay. User TTL equals to user underscore TTL dot with watermark in that event underscore, not even, it's event underscore time comma event underscore time comma it's 10 minutes. Like for example, it says 10 minutes only, right? Count events per user every 5 minutes and handle late data up to 10 minutes. Watermark is handle the late data, so 10 minutes. I think this is correct so far. Let's see. So step 1, it gave that much only, so I wrote that, and let's see. Yeah, it's little slow learning process, but stable learning process, I could say. So it depends, like, whether you want to learn in that way or not. time. Okay. So good start. Just couple of important fixes. Spark should not be caps. It's small only. For CSV, you usually read options header slash schema. Watermark part is correct. Okay. So it give format CSV option I need to give whether header is true or false. Okay. Load from events. Okay, that's fine. That's fine. Small improvement, real world. In production, you would define schema explicitly instead of relying on interface. Of course, obviously, the schema definition, giving schema definition upfront is always a better idea, always the best idea instead of depending on the system generated schema. Next step is remove duplicates based on user ID. Okay, drop duplicates. I think drop duplicates. Spelling. I need to correct that spelling as well, but it is catching everything. So dr drop duplicates. Let's write it, man. I don't want to waste my time. Let's write in a proper way instead of going making a mistake and learn. Let's learn it in a quick manner. I just want to see the drop duplicates code. Drop duplicates. That's correct. Duplicates. Duplicates. Let's see. I filled the blank and let's see. Okay, small but important nuance is this removes duplicates based on only user ID. Yeah, but ignores event time. Okay, if some user sends events at different times, only one. Okay, might be wrong. Often you can use user ID event time both. Okay. Um, Next is count event per user every 5 minutes. So the window should be group by on 5 minutes basis. So you need to specify here is window of event time, comma event time, comma 10 minutes. It's specified in the requirement. So I'll put 10 minutes. Okay. So this is the answer for the blank, and it will count based on that particular time window. But I doubt a basic gap here because the event I specified the deduplicate part for 5 minutes, I believe. What I specified here, event time 10 minutes only. Okay. Watermark also 10 minutes. Yeah, it's 5 minutes actually specified, but I gave 10 minutes. Okay, that's wrong. Okay. Good admin, but correction is needed because I requirement says 5 minutes. I specified 10 minutes. That's wrong. Yeah, that's fine. Next, so full step becomes this is and group by and 5 minutes and user ID dot count. Important distinction. Don't confuse watermark 10 minutes, late data tolerance, window 5 minutes, aggregation bucket. Final step. So here that is the difference I want to understand. For example, watermark is defined 10 minutes means it can wait for 10 minutes. How come this window will finish in 5 minutes? Late data tolerance. It means after 10 minutes it will be considered in the same kind of count operation. I don't know why. I mean, because the calculation is already happened in 5 minutes. I don't know how it will deal with the output mode will be complete, update, or mm, okay. So I need to go back to the requirement once. 1 minute. Let's go back to the requirement. This is the requirement. Write output to console. Write output to console. I think it's complete. I'll write it complete. It's taking a lot of time. That is the only drawback I could see. Claudia also is giving information, but I think this is more useful format. But I don't know. Like, I'm still in exploration stage, so I'm not sure which is better as of now. But yeah, let me refresh and see. This is a drawback I have. I don't know, like, I mean, how to deal with this thing. But as of now, I want to continue the sessions to complete my preparation uh, for the Spark. I don't think it's a system issue. It's GPT on itself will be slow. It will take up time. Most of the as per few video tutorials and some interviews I saw, right, and it is taking time. That's what I saw as of now. But we can able to fix that. I'm not sure whether we cannot fix it. I'm not sure, but yeah. So it will be like that. There is no other way around to fix this. But why update is better? Okay, windowed aggregation. Okay, count change. Okay, yeah, I forgot that scenario. It will keep on updating, right? It will keep on updating. Then it is an update, and that's the good thing. Okay, good correction. So it's update. That's fine. So enter code together. I think it was written end-to-end pipeline you built. Okay, quick append. Only final new changed rows. Complete full table every time. Every trigger every time. Then it's one important note. If window is finalized and you only want complete results, append can also be used in some windowed watermark cases, but for this scenario, update is the safer option. Okay, I think practical way in future, if we expertised in later levels, I think we may able to better understand this in a simple manner. Can you tell me why watermark is 10 minutes but window is 5 minutes? That was the confusion I have. That was the confusion I have. Please clarify. If you are an intermediate to expertise level in this Spark environment, I think you can test your knowledge by giving all the hard questions, like the level, increase the level to hard and make it little difficult for you to go a little deeper into the subject. As of now, I kept it in a steady mode, like in a simple intermediate and base to intermediate level, like beginner to intermediate level. So I'm getting the concepts and the ideas here, and after that I think, yeah, maybe we can do practical examples uh, with keep on increasing the difficulty. Once this clicks, streaming becomes easy. Okay. Hmm. So core difference. Window is how do you group the data, how long you wait for the late data. Of course, that's correct. So think like this: window 5 minutes, group events into bucket. 3 events came in, watermark 10 minutes. I will wait up to 10 minutes for late events because closing a window before closing a window. So there is, as per the watermark, as per the window 10 to 10:05, it will give the result. Timeline example. When watermark is 10 minutes. So 10 to 10. Okay. Case 1. What happens is event arrives at 10.6, also considered in this, maybe. I think so. Event time 10:03. Okay. The watermark, okay, the 10.6th, that particular transaction, right? It's supposed to be 10:03. The event time in that particular record is 10:03, but still it came late. It came at 10:06. So late by 3 minutes. Supposed to come early, but it late by 3 minutes. Even though it is late, accepted within the watermark. Okay, so in that case, I can assume in such a way, window will be less and watermark will be little more, I believe. But I'll ask the same question to GPT and let's expect the answer. Event arrives at 10:12, late by 7 minutes. Still, it is accepted because 10:12, 10:12. Okay, 10:20, late by 15 minutes. Okay, when the window time ends, there the watermark time will start. Now I got it. 10:06. It's late by 3 minutes. It's late by 7 minutes. Didn't specify the time limit time there. 10:20. It's if it is late by 15 minutes, then it is dropped because the window itself is 10 minutes. Maximum late arrival is 10 minutes. That's what it says. So now I understood. Window defines bucket. Watermark defines tolerance. It's a good way of giving a good example. That's perfect. Now, why watermark is greater than window? Usually events can arrive late. Why? Okay, you want to give enough buffer. That's correct. Example 5-10 minutes here. Spark waits extra time to ensure late data is included accuracy is maintained. Of course, even though the event come little late and it will consider, but what, how to, okay, what if watermark is less than window? Problem. Late data gets dropped too early. Incorrect results. Obviously, it will be incorrect results. Memory rule is window. Grouping logic. Watermark lateness tolerance. Watermark is a lateness tolerance. It's a tolerance. I mean, we can say watermark is for tolerance. Okay, interview one liner is window defines aggregation bucket. Window defines aggregation bucket while watermark defines how long Spark waits. How long Spark waits for late data before closing those buckets. Okay, that's pretty perfect. Quick check, don't skip. Window 5, watermark 5. If is this safe or risky? It is risky. It's risky. As if there is any late event arrive after that 5 minutes window, then it will be no, but it will wait for 5 minutes only, right? It's risky, but after that, anything after 5 minutes it came, then it will drop them. So dropping possibility is there. Right? Yeah, dropping possibility is there. Why? Window 5 minutes, watermark 5 minutes. Spark will close the window exactly when it ends. Any data arriving even slightly late due to network delay or decision lag that will be dropped leads to incomplete or incorrect counts or incorrect transformations or whatever. Best practice watermark should be greater than window based on expected data delay. That's perfect. For example, there is always a possibility of 30 minutes window. Then you need to mention 30 minutes window. Even though the record comes after 30 minutes, it should consider for that particular. Yeah, even though it won't produce the results at the time, but it'll wait. But it should not be too much. Yeah, memory rule is my watermark should allow buffer beyond the window. Final check. If your system guarantees max delay equals to 2 minutes, what would be a good watermark for window 5 minutes, 7 minutes? I think it's correct only. Since event start time, for example, it start at 10 and it will wait till window will end at 10:05. Yeah, good, that works. Window maximum delay to 7 safe buffer. Slight upgrade. In production, we often add a small extra buffer for safety. Okay, so if that is the case, what happens is expected delay 2 minutes, watermark equals to 8 to 10 minutes. So 1 minute or yeah, extra time, little bit extra time, like plus 10% extra time if you can give, that's the best way. Minimum is 1 or maybe 10%. 10% extra time we can give. That's the better way to that's the better way to so let's end this session here and we'll continue in the next session, but this is a good learning today and yeah, let's continue with the next session. Thank you so much. Thanks for watching.